In this chapter, we'll cover the advanced features of the tricarb instrument. The features covered are sample and group priostat, replay, high sensitivity and low-level counting modes, alpha-beta separation, barcode reader option. Priostat allows you direct control over several sample analysis features. Two different types of priostat counting are available: group priostat and sample priostat. Group priostat is standard on all models. Sample priostat is an option on B2910TR and standard on B3110TR and B3180TR. Group priostat allows you to count a set of high-priority samples immediately while temporarily interrupting the current protocol. You can select any existing assay for the purpose of data reduction. To operate the group priostat, load the samples into cassettes and attach the priostat flag to the first cassette to be counted. Place the cassette on the right side of the sample deck. Select Run Group Priostat from the menu bar. In the pop-up window, select the assay you'd like to use to count the samples. The instrument will search for the priostat flag and begin counting the samples. You may view your results on the display. Once the group priostat samples are counted, the interrupted protocol will restart at the interrupted sample. To end the group priostat protocol prior to counting all of the samples, select End Group Priostat from the Run menu. The instrument automatically resumes executing the interrupted sample from the previous protocol. This method allows you to count individual samples using a number of different analysis options without the need for defining an assay. It is a high-priority interrupt mode operating similarly to group priostat. The following items are available via the Run Sample Priostat menu option. Decay allows you to assess the duration of luminescence in a radioactive sample via a decay histogram. SPC decay allows you to assess the duration of luminescence in a non-radioactive luminescent sample via a decay histogram. Identify nuclide allows you to identify an unknown nuclide in your sample using the quench indicating parameters, CIS and TSIE. Optimize regions allows you to optimize sample counting regions to provide the highest figure of merit in normal count mode for samples with constant quench. Reverse region allows you to optimize sample counting region settings for a sample and determine the equivalent unquenched region settings for variable quench samples. Low-level optimize allows you to optimize sample counting regions to provide the highest figure of merit for low-level count mode. Alpha-beta preview allows you to view the sample spectrum and approximate the activity for a sample containing both an alpha and a beta emitting nuclide. Normal preview allows you to view the sample spectrum and approximate the activity for a sample using normal count mode. Low-level preview allows you to view the sample spectrum and approximate the activity for a sample using low-level count mode. Sample priostat is a manual process. You must select Count from the Run menu to initiate sample counting. To move to the next sample in the cassette, select Next Sample from the Run menu. To stop the counting of a sample, select Stop from the Run menu. To end the sample priostat counting session, select End Sample Priostat from the Run menu. The data that is generated during any of the sample priostat options is not saved. You can print the data by clicking the Print button in the report window. The Replay feature allows you to analyze previously collected data under a variety of data reduction conditions. Any modifications made to protocols during replay do not affect the original acquisition parameters. To access the Replay function, select the Replay tab in the main window. The replay tree will now appear, and then you can select the data file to be reanalyzed. In the replay tree, select the results file that you would like to analyze. A listing of the results files is displayed in the replay tree using file names. Right-click on the selected file name and select Open for Replay. On the Replay Conditions tab, you may change the parameters as needed for reanalysis of sample data, changing counting regions or quench sets used for DPM correction, for example. You may also edit the Report Definition tab to define any printed or electronic reports you would like to generate for the reanalysis of sample data. Click the Replay button. Data will be reprocessed. Any reports that you defined are generated after the reanalysis of data occurs. Data processed with the Replay feature does not change the original data. All replay changes are temporary. The limits of detection are dependent on an instrument's detection efficiency and its ability to identify background counts and separate them from radioactive counts. The TriCarb instruments use time-resolved liquid scintillation counting, or TRLSC techniques, to enhance background discrimination and thus increase sensitivity. Sensitivity may be further enhanced through the use of the optional BGO or bismuth germanium oxide detector guard that is standard on the TriCarb 3180TR. The table shows the type of correction recommended at specific sample count rates. For samples above 500 CPM, we recommend using normal count mode. For samples between 50 and 500 CPM, use high sensitivity count mode. For samples below 20 CPM above background, we recommend using either low-level or super low-level count mode. These counting modes may be selected in an assay by entering the Assay Definition page and selecting the Count Conditions tab. You may select the counting mode required by your samples by going to the Count Mode box and selecting the mode of interest from the pull-down list. The selected count mode correction method will be applied to the samples whenever the assay is used to count samples. The alpha-beta discrimination option provides the ability to discriminate between the gross alpha and gross beta activity in a mixed sample. Results are reported as CPM alpha or CPMA and CPM beta or CPMA and CPMB. One pure beta emitting and one pure alpha emitting standard are required. The beta sample is placed first in the cassette, followed by the alpha standard. We do not calculate alpha or beta DPM in alpha-beta mode. Gross alpha and beta CPM are available only. The alpha-beta standards assay is intended to only establish the optimum discriminator for the nuclide pair in that chemistry. From the main Windows screen, select File and New Assay. The Select Assay Type window will now appear. Choose Alpha-Beta Standards and press the OK button. The Assay Definition page will now appear. On the Assay Definition window, you may complete entries on the 7 tabs as described in the CPM Assay Definition presentation or go directly to the Count Conditions tab for Alpha-Beta Standards Assay Setup. On the Count Conditions tab, press the Radionuclide Name button. That will bring up the Alpha-Beta Standards Library window. Enter the name of your standards into the Alpha-Beta Standards window and press the OK button. Your radionuclide name will now appear on the Count Condition tab. Make any changes in the other tabs as described under the CPM and DPM assay presentations and save the assay. Associate your Alpha-Beta Standards assay with a protocol number and count your standards. After the standards have been counted, the instrument will automatically create a misclassification spillover curve by varying the discriminator values when counting a pure beta and a pure alpha standard. An instrument-determined optimum discriminator value is established at the crossover point of the 2 curves where there is minimal alpha and beta misclassification. The misclassification curve information and its associated optimum discriminator value is stored in the Alpha-Beta Standards library. Next, you must define an assay for counting alpha-beta samples. Create a new assay, choosing alpha-beta as the assay type. On the Count Conditions tab of the Assay Definition window, click the Name button to select the desired alpha-beta radionuclide name from the Alpha-Beta Nuclides library. Define the other available parameters as desired. If an alpha-beta standard curve has not been created, one can manually enter a desired discriminator value in the discriminator setting field of the alpha-beta sample library. Associate the assay parameters with a protocol number in the protocols tree and attach the corresponding protocol flag to the first cassette to be counted. Load the cassettes with vials and then load the instrument with cassettes. Click the green Start button at the top of the main window to begin counting. The instrument will use the selected discriminator setting to separate alpha counts from beta counts. The two-dimensional barcode reader is an optional feature that provides automated sample tracking for the TriCarb system. Barcode data can be imported directly into a sample work list, can be saved to a file, or can be used to verify existing work lists. Before the barcode reader may be used, it must be set up. This is done through the Diagnostics section of the main screen menu. To display the Diagnostics menu, select Diagnostics from the menu bar. Next, click on the Barcode Reader Diagnostics selection. The Barcode Reader Diagnostics window will now appear. Load a cassette containing vials with barcodes on the caps. Manually move the cassette so that a vial with a cap barcode is in the read position over the counting chamber. Press the Test button on the lower left of the Diagnostics window. The barcodes will be displayed in the box above the Test button along with any read errors. After completing the barcode reader setup procedure, you'll need to enable the barcode option in any assay which will use this feature. Barcode reader parameters are set on a per-assay basis and are not parameters of a specific protocol flag that is being used. Because of this, each assay using the barcode reader must be defined to enable operation. The barcode reader is enabled under the Assay Parameters tab of the Assay Definition window.